students, let us solve practice set 5.1 of the topic coordinate geometry from class 10th maths part 2. In this practice set there are some problems based on the distance formula. So we are going to use the distance formula to solve some examples. Let us consider the first problem. Find the distance between each of the following pairs of points. So let us have the first problem. In the first problem, 2 points are given, A and B, with coordinates 2, 3 and 4, 1. That is, 2, 3 are the coordinates of point A and 4, 1 are the coordinates of point B. We have to find the distance between these 2 points in Cartesian coordinate system. First of all, we should name these coordinates. So let the coordinates of A be x1, y1, which are given to be 2, 3, and the coordinates of B be x2, y2, which are given to be 4, 1. So here, as we can see, value of x1 is 2, value of y1 is 3. Similarly, value of x2 is 4 and value of y2 is 1. Now we have the distance formula, and by the distance formula we can write the distance between these 2 points, that is AB, is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square. So this is the formula by which we can find the distance between these 2 points, where x1 y1 and x2 y2 are the coordinates of these 2 given points. Now in this formula we have to just replace the values of x1 y1 and x2 y2. That is, under root we get here x2. So here we have taken x2 as 4. So 4 minus 2, because 2 is x1 as we have assumed here, plus y2 minus y1, that is y2 is 1 here and y1 is 3, that is 1 minus 3 bracket square. So the next step is AB is equal to under root 4 minus 2, that's 2 bracket square, plus 1 minus 3, that's minus 2 bracket square. And the next step we will have the square of 2 is 4 plus root square 8 of minus 2 is also 4. So we get under root 4 plus 4, that is AB is equal to root. If we simplify this further, we get AB is equal to under root 4 into 2, because we have splitted here 8 as 4 into 2, where 4 is the perfect square. So if we take 4 outside the square root sign, its square root should be taken, that is 2 into root 2. So this is the distance AB. That means the distance between these 2 points is 2 root 2 units. So this is how we can find the distance between any 2 points given with the coordinates. Let us solve another example. The same question is there. Find the distance between each of the following pairs. The points are L 5 minus 8 and M minus 7 minus 3. For this, again we have to assume the coordinates of L as x1 y1, which are 5 minus 8, and the coordinates of M be x2 y2, which are given to be minus 7 minus 3. To find the distance between points L and M, again we have to use the distance formula. So by distance formula we have Lm is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square. So here the same formula we are going to use. Here we have to just replace the values of x1 y1 and x2 y2 in this given formula. So we get Lm is equal to under root x2 is here minus 7 minus x1 is 5. So minus 7 minus 5 bracket square plus value of y2 is minus 3. So we have replaced here minus y1. Now this time y1 is again a negative value. That's why we should take it in bracket. So we will have minus 3 minus into bracket minus 8 bracket square. If we further simplifying, we get under root minus 7 minus 5, that's minus 12 bracket square, plus minus 3, this minus minus will become plus 8, that's square. That is Lm is equal to under root minus 12 square is 144 plus minus 3 plus 8. The answer will be 5 and we should take it square. That's why 5 square is 25. If we add these two, 144 and 25, we get Lm is equal to under root 169. So 169 is a perfect square of 13. That's why if we take a square root, we get Lm is equal to 13. That is, the distance between these 2 points is 13 units. So this is the second example we have solved. So if the question is there, find the distance between any 2 given points with the coordinates given, then we can use this formula, distance formula, to find the distance between those 2 points. Now there are few more examples in the textbook given. You can solve them on your own. So just try to solve them in the same manner. We'll solve the next question. The second question is determine whether the points are collinear. The points are given here A, B and C. Coordinates of A are 1 minus 3, coordinates of B 2 minus 5 and coordinates of C are minus 4, 7. We have to decide whether these 3 points are collinear or not. Now the question is, how can we find whether the 3 given points are collinear or not? Suppose there are 3 points given A, B and C on a given line. Now if these 3 points are to be collinear, suppose there is point B in between A and C, and in this case if the sum of length AB and length BC is same as length AC, then we say that these 3 points A, B and C are collinear. For example, suppose the distance AB is 4 and distance BC is 7, and if the distance AC is 4 plus 7, that's 11, then in that case we say that these 3 points are collinear. That is, if AB plus BC is equal to AC, then we say that points A, B and C are collinear. So this is the principle we have to use to solve the given problem. That is, there are 3 points given A, B and C. We can find the 3 distances, that is distance AB, distance BC and distance AC by using the distance formula. And by using that we are going to decide whether the length of any 2 segments is equal to the length of larger segment or not. For that we should find the 3 distances, length of segment AB, length of segment BC and length of segment AC. For that we are going to use the distance formula, and by the distance formula we can find the first distance AB as under root x2 minus x1 bracket square plus y2 minus y1 bracket square. Now as we are finding the distance between points A and B, so we should treat the coordinates of A as x1, y1 and coordinates of B as x2, y2. So if we replace these values in this formula, we get under root x2 minus x1, that is 2 minus 1 bracket square plus y2 minus y1, that is minus 5 minus into bracket minus 3 bracket square. So on simplifying we'll get 2 minus 1, that's 1 bracket square plus minus 5, this minus minus will become plus 3 bracket square, that is 1 square is 1 plus minus 5 plus 3, it will be minus 2 and minus 2 square is 4. So we get under root 1 plus 4, it is AB is equal to root 5. So this is the distance between points A and B, root 5 units. In the same way we can find the distance between points A and C by using the formula AC is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square. This time we are finding the distance between points A and C, so we'll treat the coordinates of A as x1, y1 and the coordinates of C as x2, y2. So in this formula we get x2 minus x1, that is minus 4 minus 1 bracket square plus y2 minus y1, that is 7 minus into bracket minus 3 bracket square. So on simplifying we'll get under root minus 4 minus 1, that's minus 5 bracket square plus 7, this minus minus will become plus 3 bracket square. This AC is equal to under root minus 5 square, that's 25 plus 7 plus 3, that's 10 and 10 square is 100. So under root 25 plus 100 we will get under root 125. Now if we simplify this by having the factors of 125 as 25 into 5, and if we take 25 outside the square root sign, we will get 5 into root 5. So this is the length of segment AC, 5 root 5 units. In the same way we can find the last length BC having the same formula x2 minus x1 bracket square plus y2 minus y1 bracket square. This time coordinates of B are x1, y1 and coordinates of C are x2, y2. So if we replace here we get x2 minus x1, that is minus 4 minus 2 bracket square plus y2 minus y1, that is 7 minus minus 5 bracket square. So minus 4 minus 2, that's minus 6 bracket square plus 7 minus minus will become plus 5 bracket square. That is under root minus 6 square is 36 plus 7 plus 5, that's 12, and 12 square is 144. So BC is equal to under root 36 plus 144. We will get under root 180. And if we simplify that, we get BC is equal to 6 root 5. Now as we have all the three distances or the lengths of all the three segments AB, AC and BC, we can have the relation between these three segments. That is, we have here BC is equal to AB plus AC, as BC is 6 root 5, AB is root 5 and AC is 5 root 5. So if we add root 5 plus 5 root 5, we get 6 root 5. That means the length of these two smaller segments, that is AB plus AC, is equal to BC. So from this we can conclude that all these 3 points, that is A, B and C, are collinear. So this is how we can decide whether the 3 given points are collinear or not by using the distance formula. Now let us have the next question. Find the point on x-axis which is equidistant from the point A minus 3, 4 and B 1 minus 4. So there is one point which is on x-axis and which is equidistant from these two given points, and we have to find the coordinates of that point. So first of all, let us write the 2 points given. Point A is minus 3, 4 and point B is 1 minus 4. Now we have to find the coordinates of a point which is on x-axis. So let its coordinate be x0. Now here we have taken the y coordinate of point P as 0 because it is given that that point is on x-axis, and we know that if there is a point on x-axis, the y coordinate of any point on x-axis is 0. That's why we have taken here the y coordinate of point P as 0, and we have assumed the letter x for the x coordinate of point P. So this is the point Px0 which is given on the x-axis. We have to find the coordinates of point P, out of which the y coordinate is already given, that's 0. Only we have to find the x coordinate of point P. Now for this one we have to use the distance formula. Now here the point P which is on the x-axis, we know that every point on x-axis has y coordinate 0, and here we have assumed the x coordinate of point P to be x. Now it is also given that the given point P is equidistant from these 2 points A and B. Now as these 2 points are equidistant, we have PA is equal to PB because they are equidistant from point P. We have to use this relation to find the coordinates of point P. Now here we are going to use the distance formula. So by the distance formula we can find distance PA by using the formula x2 minus x1 bracket square plus y2 minus y1 bracket square. And same is applied for finding the distance between point P and B. Now as we are considering the distance between point P and A, we should have the coordinates of point A be x1, y1 and coordinates of P as x2, y2. So if we replace here x2, that is x minus x1 is minus 3, so that should be in bracket square, plus y2 is 0 because we have assumed here the coordinates of P to be x2, y2. That's why 0 minus y1 is 4. So 0 minus 4 bracket square. In the same way, we can find the distance PB by having the coordinates of point B as x1, y1 and the coordinates of point P as x2, y2. So by replacing these values in the formula, we get x minus 1, that is x2 minus x1 bracket square, plus y2 minus y1, that is 0 minus minus 4 bracket square. So on simplifying this, we get x minus minus become plus 3 bracket square plus 0 minus 4, that's minus 4 bracket square, is equal to under root x minus 1 bracket square plus 0 minus minus will become plus 4 bracket square. Now in the next step, if we remove these square root signs on both the sides, that is if we squaring on both sides, we will get x plus 3 bracket square plus minus 4 bracket square, that is equal to, here also the square root sign will be removed, that is we get x minus 1 bracket square plus 4 square. This is in the form a plus b bracket square. So we have to use the expansion formula to get x square plus 6x plus 9 plus the square of minus 4 is plus 16. That is equal to, on the right hand side we have x minus 1 bracket square. So this is in the form a minus b bracket square. So we have to use the expansion formula for a minus b bracket square, that is a square minus 2ab plus b square. To solve this one, so as to get x square minus 2x plus 1 plus 4 square is 16 here. Now on both the sides x square will get cancelled. So the next step will be 6x plus 9 plus 16, that's 25, is equal to minus 2x plus 1 plus 16, that is 17. If we take minus 2x to the left hand side, we will get 6x plus 2x, that is equal to 17 plus 25. Coming to the right hand side, it will be minus 25. So 6x plus 2x, that's 8x, is equal to 17 minus 25, that's minus 8. Again, if we transfer 8 to the right hand side, it will be in the denominator. So minus 8 divided by 8, that will be minus 1. So here x is equal to minus 1. That is, the x coordinate of point P is minus 1. And the coordinates of given point P are minus 1, 0. So minus 1, 0 are the coordinates of the point on the x-axis. Now let us consider the next problem. Verify that points P minus 2, 2, Q 2, 2 and R 2, 7 are the vertices of a right angled triangle. Now in this problem also we have to decide whether these 3 points are the vertices of a right angled triangle or not. So here we have to use the property of right angled triangle. That is, in right angled triangle we can use the theorem of Pythagoras, and by that we can have the hypotenuse square is equal to side 1 square plus side 2 square. So for this purpose also we need the lengths of 3 sides of a triangle, that is length of side PQ, length of side QR and length of side PR. So we should find the lengths of these 3 segments by using the distance formula. So by the distance formula we have the first distance PQ, that is equal to x2 minus x1 bracket square plus y2 minus y1 bracket square. As we are finding the distance between points P and Q, we should treat the coordinates of point P as x1 y1 and coordinates of point Q are x2 y2. So if we replace here, we get PQ is equal to x2 minus x1, that is 2 minus minus 2 bracket square plus y2 minus y1, that is 2 minus 2 bracket square. So the next step will be 2 minus minus will become plus 2. So 2 plus 2, that's 4 square plus 2 minus 2, that's 0 square. We'll get the distance PQ is equal to under root 4 square is 16 plus 0 square is 0. So PQ is equal to under root 16. And we know that 16 is a perfect square of 4. That's why under root 16, that is 4. So distance PQ, so the length of segment PQ is 4 units. In the same way, we can find the length of segment QR by having the same formula. This time we have to treat the coordinates of point Q as x1, y1 and coordinates of R as x2, y2. So if we replace here, we get x2 minus x1, that is 2 minus 2 bracket square plus y2 minus y1, that is 7 minus 2 bracket square. And simplifying, we'll get under root 2 minus 2, that's 0 square plus 7 minus 2, that's 5 bracket square. So QR is equal to 0 square is 0 plus 5 square is 25. So on simplifying, we'll get QR is equal to 25 plus 0, that's 25, and square root of 25 is 5. So the length of segment QR is 5 units. In the same way, we can find the length of the last segment PR by having the distance, by using the distance formula. Now consider coordinates of point P as x1, y1 and coordinates of point R as x2, y2. So if we replace here, we'll get x2 minus x1 bracket square, that is 2 minus minus 2 bracket square plus y2 minus y1 bracket square, that is 7 minus 2 bracket square. So 2 minus minus will become plus 2. So 2 plus 2, that's 4 square plus 7 minus 2, 5 square is equal to PR is equal to under root 4 square is 16 plus 5 square is 25. So PR is equal to under root 41. As this is not a perfect square, we should have this as it is. The length of segment PR is under root 41 units. Now we have lengths of all the three segments PQ, QR and PR. So PQ is 4 units, QR is 5 units and PR is under root 41 units. Now can we have the relation between these three segments? If we take a square of length of segment PR, that is PR square is equal to under root 41 bracket square. So here square root and square will cancel each other to get 41. So PR square is 41. Second segment is PQ. PQ square is equal to 4 square, that is equal to 16. And QR, that is 5. So QR square is equal to 5 square is equal to 25. Now we have the relation between these three, 25, 16 and 41. Is if we add 16 plus, that is if we add 16 plus 25, that is equal to 41. That is we have PR square is equal to PQ square plus QR square. That means for this triangle PQR, the square of the largest side is equal to squares of lengths of remaining two sides. Is PR square is equal to PQ square plus QR square. And if it is the case for any triangle, by Pythagoras theorem, we can conclude that the given triangle must be a right angle triangle. That's why triangle PQR is a right angle triangle. That is we wanted to prove. Now let us consider the next question. Show that the points P2 minus 2, Q7 3, R11 minus 1 and S6 minus 6 are the vertices of a parallelogram. So these are the 4 points given P, Q, R, S. We have to decide whether these are the vertices of a parallelogram or not. So here we are going to use the property of sides of a parallelogram. For that, first of all, we should find the lengths of all the 4 sides of this quadrilateral. Is length of PQ, QR, RS and PS. And for that we are going to use the distance formula. So suppose this is a quadrilateral given. The vertices of this quadrilateral are P, Q, R and S. And we have to decide whether it is a parallelogram or not. So let us find the lengths of all the 4 sides of this quadrilateral by using the distance formula. Now, as in the earlier examples, we have used the distance formula to find the distance between any two given points. By using the same formula, we can find the distance between point P and Q. That is, we can find the length of segment PQ by using the distance formula, and the answer will be 5 root 2. You can check it out also. So on simplifying, we get the distance PQ as 5 root 2. In the same way, if we use this distance formula to find the distance between points Q and R, that is to find the length of segment QR, we get QR is equal to 4 root 2. In the same way, we can find the length of segment SR. It comes to be 5 root 2. And similarly, the length of segment PS will be 4 root 2. So here you can check it out whether the lengths of these 4 sides are 5 root 2, 4 root 2, 5 root 2 and 4 root 2 or not. Now if we consider the lengths of these 4 segments, we can observe here that the length of PQ and RS is same. That is, length of PQ and length of RS is 5 root 2, and the length of QR and length of PS are also equal. That is, QR is equal to PS is equal to 4 root 2. And we know that this is the case only for a parallelogram. That is, for any parallelogram, the opposite sides are congruent. Or in other words, we can say if opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. And here, as we can observe, PQ and RS are the opposite sides of each other. There is another pair of opposite sides, that is PS and QR. So as here we have proved that the opposite sides of given quadrilateral are congruent, that's why the given quadrilateral is a parallelogram. That is, we wanted to prove the vertices P, Q, R, S are the vertices of a parallelogram. The next question is, show that the points A minus 4 minus 7, B minus 1 2, C 8 5 and D 5 minus 4 are the vertices of a rhombus ABCD. So in the previous example, we have proved that the given quadrilateral is a parallelogram. For that, we have used the property of parallelogram. This time we have to prove that this quadrilateral is a rhombus. So for that, we have to use the property of sides of a rhombus. For that, let us consider a quadrilateral given here with the vertices A, B, C and D. We have to show that this is a rhombus. And we know that all the sides of a rhombus are congruent. So we have to check whether all the four sides of this quadrilateral are congruent or not. So for that, we should find the lengths of all the four sides of this quadrilateral. This side AB, side BC, side CD and side AD. So here again we have to use the distance formula. So by that, if we use the distance formula to find the length of segment AB, it comes to be 3 root 10 units. In the same way, we can find the distance BC by using the distance formula. It also comes to be 3 root 10 units. Similarly, distance CD is also 3 root 10 units and the distance AD is also 3 root 10 units. You can check it out whether all the four distances are 3 root 10 or not by simplifying the distance formula. Now as we can observe, lengths of all the four sides are equal, that is AB is equal to BC is equal to CD is equal to AD, that is 3 root 10 units. And we know that if all the sides of a quadrilateral are congruent, then it is a rhombus. And as all these sides AB, BC, CD and AD of a quadrilateral ABCD are congruent, that's why the given quadrilateral ABCD is a rhombus. Now the next question is, find the value of x if the distance between points L, that is x7 and M 115 is 10. This time the distance between these 2 points is given and that is given to be 10. From this we have to find the value of x. So again here we have to use the distance formula. So first of all, let us consider the coordinates of point L as x1, y1 which are given to be x7 and the coordinates of point M, let it be x2, y2 which are given to be 115. So this time the distance between these 2 points L and M is given. So we have to use the distance formula. So by distance formula we can write distance LM is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square. The distance between point L and M is given to be 10. So we should replace here LM by 10, that is equal to under root x2 minus x1, that is x2 is 1 here and x1 is x. So we have 1 minus x bracket square plus y2 minus y1, that is y2 is 15 and y1 is 7. So here we have 15 minus 7 bracket square. Now we have to remove this square root sign. So if we squaring on both the sides, we get 10 square 100, and if we square on the right hand side, the square root sign and square will cancel each other's effects. So we'll have 1 minus x bracket square plus 15 minus 7, that's 8 square. So if we simplify, we get 100 is equal to, so this is 1 minus x is in the form a minus b bracket square. So we have to use the expansion formula. A minus b bracket square is equal to a square minus 2ab plus b square. This first term square, that is 1 square is 1 minus twice the product of these two, that is 2 into 1 into x, that is minus 2x plus second term square, and second term is x, that's x square, plus square of 8 is 64. If we take 64 to the left hand side, we will get 100 minus 64 is equal to, on the right hand side we will have 1 minus 2x plus x square as it is. So 100 minus 64, that's 36 is equal to 1 minus 2x plus x square. If we take 36 to the right hand side, we will get 0 is equal to plus 36, going to the right hand side it will be minus 36 plus 1 minus 2x plus x square. So we'll get 0 is equal to minus 36 plus 1, it will be minus 35 minus 2x plus x square. So we'll have the equation x square minus 2x minus 35 is equal to 0. So this is the quadratic equation in variable x. So we have to simplify this. So if we factorize this one, we get x minus 7 into another bracket x plus 5 is equal to 0, as the factors of minus 35 are minus 7 and plus 5. So the product of these two brackets is equal to 0. That means any one of them must be 0. So either x minus 7 is equal to 0 or x plus 5 is equal to 0. For this one, if we transfer minus 7 to the right hand side, we will get x is equal to 7, or if we take plus 5 to the right hand side, we will get x is equal to minus 5. So here we get two values of variable x, that is either x is equal to 7 or x is equal to minus 5. For this one, we get two values of x, 7 or minus 5. Now let us have the next question. Show that the points A 1 2, B 1 6 and C 1 plus 2 root 3 4 are the vertices of an equilateral triangle. So let us consider a triangle with vertices A, B and C. The coordinates of these three vertices are given, and we have to decide whether this triangle is equilateral triangle or not. So here we have to use the property of equilateral triangle. We know that all the sides of equilateral triangle are congruent. So first of all, we should find the lengths of all the three sides, that is length of AB, length of BC and length of AC, and we have to check out whether these three lengths are equal or not. So for that we have to use the distance formula. So again, as we have solved some examples earlier for finding the distance between any two points given with the coordinates, same procedure we have to use, and if we use that procedure to find the distance AB, we will get to be 4. Similarly, we will get the distance BC as 4 and distance AC 4. So you can check it out whether we get these distances correct or not by having the same procedure for finding the distance between any two points. Now from this one, as we can see, the lengths of all the three sides of a triangle ABC are equal. That is, AB is equal to BC is equal to AC, which is 4 units. And we know that if all the sides of a triangle are congruent, then that triangle is an equilateral triangle. And as these three sides AB, BC and AC are congruent, the given triangle ABC is an equilateral triangle. That is, we have to decide whether triangle ABC is an equilateral triangle or not. So here also we have used distance formula to decide whether the given triangle is equilateral triangle or not. So this is how we can use the distance formula to solve some examples by using the properties of some types of quadrilateral or a triangle. So I hope you understand this problem set. Thanks for watching.